Hey everyone, welcome back to the channel. Today I'm walking you through a full DFIR workflow on a Kali Linux machine, step by step from live memory acquisition with Lime to triage and analyzing the memory dump inside the SIFT Workstation. If you're studying DFIR, preparing for the interview, or building your cybersecurity portfolio, this video is going to give you a complete end-to-end case workflow. And just so you don't miss anything, I have included an entire step-by-step walkthrough in the description section below. Every command, every step, everything you need to follow along. So let's jump in.
Let me open my notes. Okay. So here I put together a clear step-by-step digital forensics and incident response guide so we can follow to install all the necessary tools, acquire RAM safely, and analyze the memory dump from start to finish. So these notes are organized so we can move through the full workflow easily from setup to collection and deep analysis. So the first step will be to download and install Linux Memory Extractor or Lime. Okay, so the first command will be to basically we'll run this to update our package list so we can install the software. So basically update the system, and then we will install kernel headers, compilers, and Git. So all of those are required to build the Lime memory acquisition module. This command here. So the next step will be to download the Lime, this tool. So basically we are moving to /tmp temporary workspace. Then we will download the Lime source code from the GitHub, and then we will enter the folder where the kernel module source live. So I will also skip this step because I have done this. Once we are here, cd lime/src, we will run this command make, which compiles the Lime kernel module for exact kernel version. And once we set up this tool, the next command will be to acquire volatile memory, and this is the command for that. So basically this loads the Lime kernel module and writes the entire RAM into this directory here /root/memdump.lime. And then once, this might take a lot of time, depends on the size of your RAM. So I have 64 gigabits, it took so much time, but once it's done, so basically we can run this command here to confirm Lime is loaded into the kernel, and then we can check the memory dump file was created successfully. I can quickly show you this. Copy. Okay, I will do sudo. Okay, here we go, it's right here. Okay, so once we confirm everything is there, so the next step will be Lime unloading. So basically those commands here we use to remove the Lime module from memory, and then we'll verify it is gone to avoid altering evidence, and which also will restore the machine to its original state. So this step is important because it ensures that we don't keep modifying the system after dump. So this is really important to run. And then the next step will be to create integrity hashes. So basically running those commands, so we kind of switching to root user, and we will generate SHA-256 and MD5 hashes basically to ensure evidence integrity. So this shows the hash values so we can record them in our case file. And as you can see, I already did. And the next step will be to install a SANS SIFT Digital Forensics and Incident Response virtual machine. So this machine we will use to analyze volatile memory there are like so many tools inside this virtual machine, and we will use some of them. So basically we have to go to this website, create an account. Once we create the account, we can download this file here and import the file in VirtualBox. I already did this and I will show you quickly. Oops, VirtualBox. Okay, here's my SANS SIFT virtual machine. I will start machine. Okay, let's go back quickly. Okay, so after setting up a SANS SIFT virtual machine, we have to enable file sharing between Kali Linux, which is host, and virtual machine. So here on our Kali Linux machine, we'll run this command to kind of verify the memory dump exists, and then we will create a folder to share with VirtualBox, and we will copy the memory image into that shared folder. Once this is done, so inside the VirtualBox, before we start SIFT VM, we have to also enable file sharing between host and VM, and I will show you quickly how to do it. So we will go here, settings, and share folder, and as you can see, I already have done this. I added my /home/nermin path, and it's right here. So folder path, you will find your folder path and just apply and click OK. That's all you need to do. Okay, and then inside the virtual machine, we can check that the share folder is mounted, that actually the folder exists. Okay, let's do this. Okay, here we go. So everything is here. Let me show you. Maybe somewhere on the top. I saw it. Oh yeah, here we go. I have done this twice. Right here. Yeah. It's right there. Okay, let's go back to notes. Okay, now we can start using some of the SANS SIFT DFI tools, such as a bulk extractor. So this command here basically extracts artifacts such as emails, URLs, IP addresses, credit card numbers, and metadata from exchangeable image file format. So let's run this command in VM. So this might take a little bit time, so we can move on and come back to this one. We'll open the new window, go back to the notes, and then we'll run the next command. So basically this one helps us to find the command in our history, list extracted files, and it shows sample output, like for example email found in memory. Let's run this one too. There we go, we got some data. Close this window, open the new one. This one's still working. Let's move on. So the next one will be a string plus grep. This is good for IOC's discovery. So let's run this one. So basically this command search raw memory for keywords like passwords, SSH info, or anything suspicious. There we go. It's working, and again it will take some time to complete the whole process, and I will not go through those data because it will take forever, so you guys can do that on your machine. Let me open the new window and again move on. So the next tool in SANS VM is called Foremost. It's used for file carving. So basically we are going to make this directory /foremost-out and run this command here. So I already have done this, so basically I will just go straight to this directory. But basically this recovers embedded files such as PNG, JPG, zip, exe, PDF, and scripts from memory. So let me go to this directory, and then we can go from there. Okay. So the next command will be this one here, ls-lh, and then we will go to this again directory to see what is inside. So basically this command lists the card files by type. Okay, as you can see, we have here different directories, documents, executables, so we can now dig in. So I will go with this one, exe. So basically the next command, let me go back to notes. So we're going to view extracted executables in .exe. So basically this shows extracted executables, which is kind of candidates for malware. So there are a lot of those files, and we can pick any of those and dig in. So again, let's go back to notes, and the next command will be file, and then we can choose the file. I already did. So this kind of, it says there is no this file. Okay, let's try something else. Let's try this one. Oh, I know why. Let me go back. Not in right place. Okay, let's do now. Okay, here we go. So we found some file, and basically this command like detects the file type, like PE, DLL, or malware loader, for example. Now we can run the next command. Let me go with this file. I think I did this file before. Let me run this again. Okay, yeah. Is this the same one? It's not the same one, but yeah, it's the same type of the file, DLL. Anyway, so let's dig in. So the next command, it will be to identify metadata from the file. We'll run this command here. Okay, so let's see what we have here. So this is this is current file bin64 DLL, which is recovered from memory, and it looks like it's corrupted or incomplete, which is why exit tool shows strange fields like subsystems and timestamp with all zeros. So what does this warning mean? So it says here error processing PE data directory. So it means that DLL's portable executable header is damaged or partially overwritten in memory. So exit tool cannot pass all internal structures. This is common with memory card executables. So what this usually means in DFIR, so the file may be malware or part of malicious injected module. It may be a partial dump of DLL that was loaded into memory. And for example, the tool for most often recovers fragmented or incompleted executables, so header corruption is normal. Or it can be unusual values like this one, subsystem EFI boot service. So this often indicate header corruption, that it's truly an EFI component. Okay, let's move on. Okay, the next will be this command, strings -a. So basically this pulls readable ASCII strings to see potential APIs, URLs, commands, or malware behavior. So let's run this one on the same file. Okay, we got some data. Let's see what is the next. Oh yeah, so the next one, we can generate SHA-256 hash. I will not do this. I have done this. It takes also time. I will skip this, but you can guys do by yourself. Basically, you will run this command right here once you run the previous one. I will just quit this, move on. So now we will pull more strings using this command. So basically we are going to search for keywords related to bootkits, keyloggers, hooks, or loader. Oops, wrong command. Okay, we got some data. Again, I don't have time to go through all of this, otherwise this video will last for like more than 2 hours. Let's move on. So the next tool is called YARA, and it's used like for detecting types of malware, IOC matching, and kind of keyboard detection. So basically we use YARA rules to detect malware families or suspicious patterns inside memory. Let's run this one. This might also take some time. I think I know why this happened. Oops. Let's go from this directory. Okay, it's working. Again, it might take some time. As you can see, this is still working. I will just stop this, close this window. Let's go to the first one. Yeah, it's still working. This one is still scanning. I will open the new window and move on. So basically I will run the next command, but before I run that command I will just open this file. So basically this creates and runs a custom rule to catch any text or binary pattern. So I will just open the file before running this command. So here we go. So basically we created the rule in YARA tool. Again, we use this to catch any text or binary pattern. Let me go from here and run the command. This can also will take some time. Okay, let's go back to foremost directory .exe and run this command. Let's see what happened. So basically this command here, it's used to check extract executables for credential theft, URLs, malware indicators. Again, we got some data, a lot of those things. Now we can run strings-a and choose some file. This basically finds all hard-coded URLs or C2 servers inside the malware. This is just example. There we go. And I think we are done with SANS SIFT VM. So those are just a few tools that I used for analyzing my volative memory. But there are like so many other tools you can use, and there are so many other types of scripts and commands that you can use to analyze your RAM. Okay, let's move on. Okay, now it's time to collect Linux logs. So I already have done this. So basically we are creating this directory /root/DFIR. So we will put all collected evidence in this directory. So I have done this. So let's move to the next command, which is collecting logging sessions. So I will run this command now to collect logging sessions. So basically this command collects logs of user sessions like local logins or GUI logins. Okay, let me run the next one. SSH authentication events. That's the next one. So basically this command, let me run first the command. So basically this command will export all SSH logging events, both like failed and successful. Okay, move on. Sudo usage. And okay, so basically this gives us a complete history of privileged command usage, which helps us to identify what commands we run with root privileges, if an attacker escalated privileges, or if suspicious commands were executed with sudo. So basically, this command like pulls all logs generated by the sudo command. So every time someone types sudo something, it also saves those logs into this directory /root/dfir/sudo.log, and this here, the last command right here, so basically hides the output from the terminal, so it keeps our screen clean. Okay, let's move on. Okay, so this one is used to collect all authentication failures. Let me run this one. So basically, again, it loads the entire system log, filters for anything related to authentication problems, failed logging attempts, generic authentication failure messages, PM authentication errors, invalid user logins, and this right here, from here to here, this command saves all matches into our folder, which is a DFIR evidence file. Basically, this gives us a file containing all potential authentication problems like brute force attempts, invalid user logging attempts, password failures, PMM module errors, failed SSH logins, and failed sudo attempts. Okay, so now it's time to analyze those logs. So let's run the first one for so basically all those commands are related to SSH brute force attempts, and we already collected those logs in this file ssh-out.log. We might not find anything here because I never enabled SSH. I never created any SSH keys, and I never logged into this machine using SSH, so we will not get anything, but still I will just quickly run those commands and explain to you each of those. So again, there is nothing, right? But basically this command searches the SSH log for failed logging attempts. This tells us whether brute force attacks or password guessing attempts are happening. Okay, let's run the next one. Looking for some IPs. Okay, so this one filters only failed SSH logging attempts, then it scans each log line and prints the word immediately after from, which is the attacker's IP address, and then sorts all IPs alphabetically, and then counts how many times each IP appears, so number of attacks per IP, and then it sorts like counts numerically from highest to lowest, and then it displays the top attackers. Again, there is nothing. Basically, this command we use to identify the most aggressive IPs attacking our SSH servers. So this is really great for reporting brute force sources. Okay, let me run this one, and again this will not display anything, but basically this is finds all failed logging attempts again, extracts the username attacked, the word after 4 in SSH logs, then it sorts usernames alphabetically, counts how many times each username was attempted, and then displays most attacked username first. And why it's used in DFIR, it basically shows whether attackers are trying to root, admin, test, or invalid usernames. This helps us identify targeted accounts and possible brute force strategies. Let's move on. Okay, so the next one we checking if anyone got in. This is for successful and failed SSH logins. So basically we are searching for successful SSH login events, and again it will not show anything here, right? Looking for all sudo commands. We got something, yeah, we have sudo commands. Okay, we got something. Okay, let's move on. Okay, so now we are going to filter by user. Okay, let's see what happened here. Okay, we're getting some data. Good. Okay. Okay, this is failed sudo attempts. Basically here we are like searching for sudo password failures. It's useful to find root password guessing. Again, we're getting some data. Let's move on to the next one. Sudo activity. So this is for latest sudo activity, and as you can see here, we're going to display the first 20 sudo actions in the log, or maybe the first 20 lines. There we go. Oops. Okay, all new sessions. So this will show when a user logged in local terminal or GUI. Now we're looking for removed sessions. Basically, it shows when a user logged out or a session ended. There we go. So this is for authentication failures. Okay, let's run this one and move on. Okay. We're getting some kind of data. Okay. So this command here, like, basically finds errors from Linux authentication modules. PIM. Okay. Let's see what's the next. Okay, invalid users. So this will show attempts to log in with usernames that doesn't exist. Basically typical brute force behavior. This was me. Okay. Okay, the next one will be this one, repeated failures. Basically this counts all failures, useful to measure brute force intensity. Okay, we got some number 3024 of those. Basically this means that our system recorded 3024 authentication related failure events in the journal logs. So what these failures usually represents: on Linux, failed in authentication logs. Typically, on Linux, failed in authentication log typically includes like failed password attempts, failed sudo attempts, failed PIM authentication, SSH attempts, failed service authentications, logging sessions, invalid user attempts, and lock and unlock errors. But this doesn't mean that there are like 3024 SSH brute force attempts. So only that the journal recorded those failures of the different types. That's all. So it doesn't mean that there will be like 3000 SSH brute force attacks. Okay, let's move on. Okay, so now let's move to malware detection. So here, let's run this command first, and then I will explain. Okay, so this is cron job startup persistence. So basically list user cron jobs, shows roots cron jobs, it shows a system-wide scheduled task, and it's used to detect malicious scheduled tasks. That's all about this. We'll move on to the next one, all systemd services. So basically this will list all running services. It is used to find suspicious or unknown services, basically. Okay, we got something. Okay, let's see what was the next. Okay, so this one includes disabled and masked services. It will show installed services running or not, and it helps locate malicious startup services. Okay, disabled, and okay, let's see, we run this one. Okay, so the next one, we are looking for suspicious new system and systemd services. Well, basically we are searching logs for service creation or failures. Okay. Okay. So the next one, we're checking user startup files. So we're looking for persistence via startup scripts. And this might also take some time. I'll just stop this and move on. Okay, checking startup scripts. We already did that. Let's run the next one and see, is there something? Yeah, there's something. Again, we will not go through those data. Let's move on. Okay, checking running processes. Basically, this shows tab processes. It detects crypto miners or malware. Again, there's some data. Okay, this one here, this command here finds possible reverse shells, Python malware or unauthorized downloads. Okay, the next command is this one. I will not run this, but basically because it will show some sensitive data. So this command lists all open ports and processes using them. So it's used to detect like backdoors, malware listeners, or unauthorized services. So I will not run this one, but I can run the next one. The next one will check TMP folders for malware. So these folders, those folders here, are commonly used for malware, crypto miners, or memory-only payloads. Well, let's see what's the next. Okay, let's run this one and then I will explain what's going on here. So basically this shows like if anything is set to start on boot, and probably there is no this file. Yeah, it says no such file or directories, which is normal on this Kali Linux. So what does this mean? So modern Linux systems, including Kali, no longer use rc.local by default. So the file simply doesn't exist. This is normal and doesn't mean like anything is wrong. But it's sometimes this can be used by attackers to set up basically anything to run like when we start like on boot. Let's run the next one. I think it's checking SSH authorized keys. There is nothing for sure because I never created those keys, and it will it will say no such file or directory. So basically, SSH key logging is only used if you manually create those keys for user or for root. Because I never added any SSH public keys, these files do not exist. So the system correctly reports no such file or directory. Okay, and let's see what's the final step. Okay, so the final step, we create a directory called DFIR hyphen case. I already created this, and we copy all files from this directory /root /DFIR that we also created to the folder, and we also copy everything from our memory dump that we collected using a tool lime to the same folder, and then we can check this folder exists. Yeah, here we go, there's the folder with those files, and then you can zip the folder, and I already done this. Let me just check my zip folder. Yeah, here we go. So everything is here. So basically we can use all this data and findings for our final report. So this is all for today. Thank you for watching, and I will see you in my next video.